Okay, welcome to mini project 3. We're going to do some deep learning with Pet Finder in this one. So our main task in this is to create a notebook that will help we'll work on this Pet Finder Adoption Prediction Challenge in Kegel. Kegel is a well-known machine learning environment or website that hosts a lot of challenges here. So if I go to Kegel actually, and if I just go to compete, there are lots of challenges. Some of them have money associated with them, and some of them are just for knowledge or for learning sort of stuff. This is actually a challenge that happened like over a year ago. That was set up for Pet Finder. So you'll have to make sure you have an account in Kegel. You can use your, I think your Gmail account and sign up with that. And the challenges are generally set up this way with these tabs here. There's an overview with descriptions, the timeline, description of prizes if they are, and kernels. Then there's a link to the data, and you generally have to have signed up for this challenge and accepted the terms to see the data, and the data is here. I've already downloaded the data into GitHub so we can access it later, and we'll talk about accessing this specific data here also. We're not we won't be using all the data. There's a bunch of images of the pets and things like that. We'll be ignoring some of that at this point. There's also the notebooks. These notebooks will be similar to your notebooks we've been using so far in this class. Same sort of what are often called Jupyter notebooks. There's a tab here for your work, but there's also a tab here, public notebooks, and they're all ranked by votes. And so it's interesting to see how different people are attacking this problem and what they're using here, and hopefully some of this stuff will make sense. Like here's a boost model. So again, remember we looked at ensemble models that boost this, and this looks like this is a 6-place solution. A lot of the since it's a completed challenge, some of the solutions will already be posted here. So you feel free to look at these. So like I say, sometimes these notebooks are interesting. So like this first one, one with the most upvotes, is just an exploration of the data. And again, it kind of just goes over some information, explores the data set, reads it in, displays it. Most Kaggle competitions have a couple of these notebooks people create. They kind of just explore the data and show this. So they're not necessarily trying to solve the data or the problem right now. They're just exploring the database and what is the data to give people kind of an overview of what's going on here. So that's always interesting to watch. Then there are always some good solution or some sample solutions. Usually there's a good what's called a baseline model, a very simple model. Unfortunately in this competition there wasn't a good baseline model. I mean there was, but it was just too complicated. So there's a baseline model, again similar to what we've seen before, kind of what we see. We import some libraries, break the data up into training and testing splits, and then start processing that. But they do a lot of processing on this data, and it's all this is in Python, but again it's not using some of the methods that we've used in scikit-learn or other places like that. So I didn't find this baseline model all that useful, so I created our own baseline model here. Here's a sample 6-place solution. Again, unfortunately, this is getting a little more complicated than what you can understand here. But kind of gives a nice overview, some documentation. They're actually running 3 different neural networks here and then combining them together. They're doing a bunch of pre-processing here of the data, and we'll be talking more about that. And then they're using these different neural networks together. They're also doing some image training on this and setting this up. But again, some of this will make sense. So here we're importing our libraries. They're using scikit-learn. Again, in Keras, both libraries will be using. They're using Torch as a backend instead of TensorFlow. So some of the stuff, and this person tends to write more to Torch rather than Keras here. So again, reading in the data, and so sometimes it's useful to look through these and see, but at this point you're probably not going to be able to understand much of these libraries, though there should be areas you can understand. So like here they're looking at certain features and combining those in different ways for this. Adding and dropping features from their data or from their list of data they want to train with. But when they actually set up the neural networks, they're using Torch directly and creating tensors. And again, we're using Keras, higher level language than this. So again, a lot of this information is just not all that useful to you, unfortunately. Okay, but again, your notebooks will be here. So that's the idea of this TensorFlow stuff. So let's just go through this back to our beginning project here. So we've got I'm going to run this. We've got all of our libraries that are being imported, and then again links to this. And this is all the data, the main data in the Pet Finder challenge here. We're looking at a database of pets in Malaysia, and we're trying to predict the adoption speed here. Oops, sorry about that. We're trying to predict the adoption speed for this, and we're giving this information to type of animal, cat or dog, the name, the age, the breed, the color, all these different information things. And again, we're trying to predict this adoption speed. 0 means the pet was adopted the same day it was listed. 1 within 1 or 7 days, so the first week. 2 is first month. 3 is within 90 days, and 4 is after 100 days of being listed. So that's what we're going to predict this as a categorical thing. You could actually set this up as a regression and get a number between, like, say 2.5 or something. So you could set it up as a regression model, but we're going to do it as a categorical model, and we're going to put every pet in one of these categories things. We've got training and testing data here. So let's look at how we've set this up. So I've copied the data into a GitHub repository and set that up. Now later on when we get to Kegel, we're going to have to use the data inside Kegel, and so eventually we will comment out this line and uncomment this line when we're in Kegel itself. So we use the official Kegel data for this. Okay, then we're breaking. So again, we're reading this data. There's a bunch of training data, and then there's special submission data that we've got to create a submission for, and that's unlabeled. We don't know what the labels are for that. So that's what we'll see here. There are about 15,000 pets. There are 24 features, or actually 23 features, and then the adoption speed, which is also given. And in the submission data, there's about 4,000 pets. But again, we are just given the 23 features, and then the adoption speed we have to predict. So that's the submission we're going to come determine. So again, we'll run this. And then we can take a look at this data a little bit, the different features in here. And we're going to select certain features. In this initial thing, I'm just going to select 4 features, 4 columns basically here. The age, etc. So we're going to select the age, the gender, the health, and the maturity size. These are all numbers. So the age here, maturity size, and the health are all numbers that we're going to process. And then we're going to predict the adoption speed, and again we're going to use this as categorical stuff. So we're going to use what is called one-hot encoding for this for the output. So let's go back up here. So we'll look at the output will be 5 different nodes, and corresponding to 0, 1, 2, 3, 4, 5, 4, these 4 different categories. And then we'll use, so if the pet was adopted in the first week here, this node will be active and the other nodes will be 0. So we'll have 1 active or 1 node, and the run will be 0. Again, if the pet's never been adopted or was adopted after 100 days, this one, the 4th one, would be active and all the other ones will be 0. Now we call that one-hot encoding. One of them is on or hot or 1, while the other ones are 0. And we use this special call to, let me go back here, to categorical, which is in scikit-learning, which lets us do that. So here's our data. Our training data will be, again, 15,000 pets. and we only are taking 4 features from it. We're doing the same thing for the submission data, because we want to treat the training and the submission data the same always, because we're going to use the same algorithm or same model on the training as on the submission. So the submission data is again about 4,000 pets with 4 features each, and then the output is again this 15,000 pets, but now we're using 5 output categories for that. So we can actually do some more ways of processing this data and stuff. There are a number of issues with this data and how we process it. So like the color is a numeric value. There's 3 different colors. Things like the vaccination deworm rate, gender. So we'll talk about some ways of handling that in a future posting. So I'm just going to skip over this for now. And we'll look at different ways of modifying features into different categories and things like that later. Okay, so now we're going to actually scale our data here. So I'm going to go on and run this. So I'm going to create a scaler, and I'm going to make sure I run the same scaler on both my submission data and my training data that we have, so that if we're going to run it on one, we have to make sure we run it on another one. And then we're going to break our data. So though we have submission data, we can't really see how that's doing. So we're actually going to take our training data and break it up into a training and testing split here. So we've got about 10% of the pets held out just for testing as we go. And here's our neural network we're going to define. Now, your input and output sizes will change a little bit, and so this code actually looks at your data and sets the input size to the size of your input data, and again the output size. This should generally always be 5, but it does the same thing. It looks at your output data and automatically sets it to the output size. We're going to create a sequential model, and we're calling it model. The first thing we're going to add is a dense layer, and again you can try different layers. This is a very simple network with 20 units in it, and then the input size feeds into this first layer. I'm going to skip over this dropout stuff for now. We're going to add another dense layer after that with 10 units, and then we're going to add our final output layer here, a dense layer. The output size, it'll be 5 units, and this is going to be a softmax layer, and this makes it the output layer. Softmax guarantees probabilities are set up so that these add up, and it'll figure out which of these categories it should be. And again, in our other layers, we're using these rectified linear units, which are common these days, instead of the sigmoid units for this. So once we've set up that network, we compile the network. We use a certain optimizer, and again, we calculate the loss, and we use a certain way of doing this that's set up for categorical data. And we're going to try to measure the accuracy. So a metric we're going to keep track of is accuracy here. So we're going to compile that network and then print a summary of it. Now, dropouts are one way of preventing overfitting, and again, we haven't covered dropouts yet in this course, so I've just commented that out. And later on, we'll see ways of doing dropouts, but or other ways. But one of your goals will be to maybe try out different sizes and types of neural networks. And initially, when you're doing this, there's no great way of doing network design. There's no obvious solution. There's no calculations you can make on what's the best network solution for this. In fact, even today with networks, people are proposing different network structures, different connections, and trying to find the best way. So this just gives you some experience with trying to think of what might be a good network solution. So here's our simple network. It's a very small network. It only has 360 parameters. We'll soon be looking at networks. In next unit, we'll have 1,000,000 parameters in them. So these are what are called callbacks, and for now I would just leave these be. We'll talk about these. These are actually covered in the second half of chapter 10, but I decided not to introduce them yet. But what this is doing is changing the learning rate here over time, and the patience is how quickly it changes the learning rate. So if this is a smaller number, it's less patient and will change the learning rate more often. Again, early stopping, again, you can run this for a while, and this will stop if the network is not improving very much. And again, the patience here. So right now I have the patience set really high for this, so it will generally not do learning stopping. And again, you can set this up so that it would save your model at different times and always keep the best model out there. But again, I would just leave those alone for now. You can just run that that model, and we'll learn more about that later. And so here's where we're actually training our model. We're using the X-train and Y-train data. We're going to do this for 10 epochs. You'll probably want to do this for like 100 epochs. Here, let me just get this going. And then we're using these callbacks, which are defined up here. So it may do learning rate reduction sometimes for this. And then again, we're using this validation data where we save some of the data off. One thing we'll see with this is that the network does not perform very well on data it has not seen before. It tends to overfit the data. You'll see that the accuracy is not very good here. We're only getting about 35% accuracy. And but that's okay. If we could actually get that in the submission data, we'd be very happy. We won't. Because the submission data, again, we tend to learn overfit for the data we're training on here. And so if you actually go to pet adoptions, you can see the leaderboard. This again, so the top finisher was actually got 45%, was the best accuracy anyone got here. And a lot of people got just under 20% accuracy for that. So. And our model should get around 17% accuracy, and hopefully you'll be able to improve upon that for that. Okay, so and again, you can run this. You may want to run this for longer than 10 epochs. Luckily, this data is still relatively flat and stuff. And so here I'm running it for more epochs, and I'll see that the learning rate is being reduced over time. You see the learning rate is reduced at different times automatically, and that's this callback being run that'll reduce the learning rate. And right now it's cutting the learning rate in half each time, as long as things don't change after a while. But again, our accuracy is not changing much. In fact, accuracy was just not improving for like 20 updates in time. So although I said to run it for 100 epochs, it's actually stopped at 41 epochs with this early stopping. And again, that's tied to this this checkpoint here. If it sees like 20 epochs in a row with no improvement, it stops the process. So our final score was about 36% again on our testing data. And then this is kind of a graph. So this shows the loss. And again, we're still having loss, so we should still be learning, but we're just not here. If this loss drops to 0, then we're not learning anymore. But we can just see as we look at the accuracy that the accuracy increased, and we see a little bit of overfitting again, where the training accuracy is here, but the actually this isn't. The validation accuracy is actually higher than the training accuracy here. Interesting. So that's not overfitting. But again, for a long time here, from like 20 epochs on, we really did not see any improvement. So our model probably just is not complex enough to do any more improvements here. Okay, so now that we have a basic model, we're going to submit that model to Kegel here. But in order to do this, we actually have to go to Kegel and upload this notebook into Kegel. So what we're going to do is save this notebook. And we're also going to save a copy of this notebook here. Oh, actually, we're going to download the notebook. That's what we want to do to our local machine. So I'll just leave the name the same here. And save it to my folder here. Okay. I'm saving that out there. Now I'm going to go to the Kegel pet adoption challenge here. Again, you should have you'll have to join. Make sure you have an account on Kegel, probably tied to your Google or your CIS account through Google, and then you'll have to join this challenge. And then under notebooks, go to your work here. So under your work here, you're going to create a new notebook. And to try to prevent cheating, what they're having you do is actually upload your notebook, and they will run your notebook and then run their data against it for this. So again, you can leave this language to Python. You can also select R here, just out of if you ever wanted to, and it's a notebook, and we'll just create this notebook. So it just creates a draft notebook for you with imports a couple libraries and sets up the input file to this Kegel input area. And in this area, the data has already been loaded in for you into this area. Now we could have actually done our whole development in here, and you can do your development in here if you want once you get a basic notebook in here. But again, since we were using Colab notebooks, I thought we'd start there. So remember we were in here, we downloaded that notebook. Now we're in Kegel. We're going to want to upload our notebook into here. So we're going to go to our notebook here and find it. So here's our notebook I downloaded. It's IPYNB. These notebooks used to be known as Iron Python notebooks. So that's their acronym for that. So we're going to import that. And so that should bring in your notebook here. And now we can, now we have to go through and change one thing. So if you scroll down here to where we're bringing in the data, setting up the data here, there's two different folders, one in GitHub and one in Kegel, and we've got to use the Kegel one. They won't let you grab data from GitHub here. So here, where we set the data folder to the GitHub folder, we want to uncomment that out, and we want to comment in, or we want to uncomment the Kegel folder and comment out the GitHub folder. Okay, now we could just say run all, and I'm just going to go through this and run it here, and again, hopefully they'll have pretty good processors here, so it won't take you that long to run this. But you can then run through your notebook here, and it runs very similar to the other ones. They'll tell you a little one there as you run these different cells. So this should look very similar to Colab here. Let me see what the error is here. Okay, so Kegel, they changed the data folders. Rather than just having an input folder, they now have a subfolder in that. So since last year when I did this competition with another class, they've changed it. So I've adopted this. So now with this change, we'll read in the data. So our data is read in. We can display the data. Yep, it's all there. Select our features. Again, we're using our 4 features we've selected here, and categorical output here. We're going to, again, skip over some of this optimization stuff. After you get the basics done, I suggest you go back here and watch this video for hints for improving your score that will talk about ways of selecting other features and modifying those features, and this code here is in that video. Again, we're going to split the data up, or scale the data and then split the data up. We're going to set up our network here that's run. So there's our network, define our callbacks, train our network. For this, I'm just going to do for training for 10 epochs for right now, so we can get through this. And again, this runs it on Kegel, and Kegel has pretty fast processors that they give you access to, so it should train relatively quickly. Again, I'm getting accuracy about 35%, but my results will be much worse actually. I can look at my results here. So my accuracy is getting up and beginning to plateau. And so here's the important part where we have to create our submission. So we're going to just look at our data for submitting data here again. We're going to make a submission class. They want a file called submission.csv to be created in your notebook where we're predicting the adoption speed. So this code does that all. And one thing that's nice, I mean, the baseline notebooks that are usually provided have this code usually in them. So that's why I remember when we were looking at the different notebooks that often what I do take from those baseline notebooks is the code for reading in the data and the code for creating the submissions here. So now we've got our submissions created, and then we want to submit this to Kegel. So let's look at how we have to do this. To do this, it's kind of like what is called GitHub, in that we've got to save this version, and then once we've saved it, so this is saving version 1. Oops, before I do, I'm going to give it a name. CIS 6115 at Finder 1. Okay, I'm going to save it. You can create different versions. I'm going to leave that just at version 1 recorded. And then a quick save will just save your notebook, similar to what save does over here in Colab, where it just saves your notebook. So we could certainly just do that and that'll save it. But what we want to do now, oops, it's creating a saved version. I'll just wait a sec for that. Is I actually want to save and commit it where it will run the whole notebook, all the information in the notebook. Now, one thing that we'll do is earlier I skipped over these some of this code for classifying the data here and breaking and doing certain categorical columns, and it is actually going to do that stuff. So okay, so now it's saved the short way. Now I'm going to do a full save, and this is a commit, and this will let me do a submission from this. So I'm going to do that. So it will not only save it, but it will commit it. And commit is language that's familiar if you've ever used GitHub or other source control systems. So it just tracks each version and makes sure you have a different version available out there for each time you've saved. So again, it will be creating this, and this could take, again, it has to run the whole notebook, run all the cells in the notebook, and right now this will probably just take a couple minutes, but later on, when we get to larger Kegel competitions, this might take an hour or so to run, to do a commit, and so you certainly don't want to do these commits every 10 minutes, especially if they just take an hour. So. Okay, so now that's saved and committed. I'm going to use this back arrow to go back to Kegel. Leave the editor, that should be okay because I did a save here. Okay, so here's my notebooks here. Here's the version I created, so I'm going to click on that. So now I'm not in the editor yet. If I wanted to go back to the editor, I'd hit edit here. But I'm just looking at the notebook information. It gives me an overview of the notebook here. And there are different tabs. So this is the notebook, the input, the output, execution information, log. I'm going to click on output, or I could just scroll down to the output section. And here's my submission file here. And I want to submit it. It's looking like it has a problem. A notebook cannot use internet access in this competition. So let me check on that and look right back here. Okay, I had to go back and edit my notebook here, go in the edit mode, and then under settings there's this internet setting, and you have to make sure that that's off, and then you can save your notebook again and do it for the commit, and again it'll rerun your notebook. So yeah, your internet access has to be off here. They've actually had a fair amount of cheating and issues with cheating with different Kegel competitions, and you actually see that the Pet Finder one group, the top winning group, actually cheated and was found out and was their award was taken away from them after that was discovered. So they've tried to institute more controls into this system, especially with these challenges that have a fair amount of prize money associated with them. Okay, so we're just waiting for this to run and finish up. Now, when this runs, it should usually pop up a little view option. If you hit that right away, it'll actually bring you back to the editor here directly. You can go to output, and now, as long as your internet is off, you should be able to hit this submit button. You can hit submit, and that will submit your scores. It'll take a couple seconds to process your scores. Okay, looks like they've changed just a little bit too, so they're actually rerunning the notebook during the submission, and they're saying that this might take a little bit of while. We'll let this run. So far, it's been over a minute. It's running. And eventually, our score will show up here, and we'll see our results. So that's the basic idea of this Kegel competition, and this mini challenge for this. So remember, for your job, besides just doing the calendar, you have to do a little write-up here. So again, the first part of the write-up is to sign up for the Kegel challenges and to include your Kegel ID here. Next one is to talk a little bit about what features you think are important to this and why you select what features, and then how you change some of them to categorical features, or what other things you did. And I assume there'll be a fair amount of discussion in the discussion areas on this this weekend. And then talk about your submissions, describe the different attempts you made to improve the notebooks and how you did. How did your Kegel data submission perform as compared to the test data, and stuff like that. So just kind of summarize your experience with this. Again, I don't expect you to get amazing results. I just want you to get familiar with neural networks and this Kegel challenge and learn the basics. So you certainly won't be scored on how well your notebook performs. It's just how well you write about the features, and what features, and how you write about this process that will be important for this challenge.